So we'll try to solve some problems on controllability and observability. So let us take the first problem on state variable to find controllability, observability. Now the problem statement goes like this. The state model of the system is given by x dot is 0, 1, minus 1, minus 4x plus 1, 0, u. This is state equation, and y is equal to 0, 1, x. Find controllability and observability of the matrix. So you just extract ABCD matrices from this. The A matrix is going to be 0, 1, minus 4, and B matrix we know from it is 1, 0, C is 0, 1, and there is no D matrix which is 0. We have test available, Kalman's test. Using the Kalman test we can check whether the system is controllable or observable, or uncontrollable or unobservable. So when I say controllable, we know that it is completely controllable. So for that, let us write controllability matrix. We know M is equal to B, AB, because it's a second order system, you will be getting only two terms here. So B we know it is 1, 0, then we have AB, we can multiply A and B, that results in 0 and minus 1. Now, so we can write the matrix M that which results in 1, 0 and 0 minus 1. Then what I can do, if the rank of this matrix is equal to order of A we know it is 2, the rank we need to find, otherwise find of the data of it. Whether it is equal to 0, it is uncontrollable, it is not equal to 0, which is controllable. Then if you find AD minus BC for the simple 2 by 2 matrix, M matrix, then it is going to be minus 1, which is not equal to 0, which is not singular, which means this particular system is completely controllable. Similarly, we can do the Kalman test for observability also. We know the observability matrix N is equal to C, CA. So again the two terms will come because of the order 2. So C matrix we know it is 0, 1, then we can get the product of CA which results in minus 1, minus 4, then we can concatenate in 1 by 1 row, then it will be getting the N matrix as 0, 1, minus 1, minus 4. Again find out the data of it. The data of is nothing but 1, which is not equal to 0. I can say the system is observable. When I say observable, it is all the states are observable, completely observable. Similarly, we can look at the second problem in this. The problem statement goes like this. The system model of is state space model of the system is given by x dot is equal to, we have minus 1, 0, 0, minus 4 plus bu, and y is equal to cx. A. If B is 1, 0 and C is 1, 1, obtain the controllability and observability. B part. If B is 1, 1 and C is 0, 1, obtain the controllability and observability of the system. C part. So B is 1, 2 and C is 2, 3, obtain the controllability and observability of the system. D. Comment on above result. So in this particular system, B matrix, C matrix are not given directly, and we have parts of the problem A, B, C, D. So in each problem we have a B matrix and C matrix. We try to find the controllability, observability, and we'll try to draw some conclusions from these three cases. So let us start with the first case where B is 1, 0 and C is 1, 1, and we know that A matrix is minus 1, 0, 0, minus 4. And of course D max is not there, D is 0. So we can do the controllable test very easily. M is equal to, we have a B, AB. So B we have already taken 1, 0, AB you can multiply it, A and B, that is going to be minus 1, 0. Then if you find the data of M, the data of M is going to be 0, which means the system is uncontrollable. The system is uncontrollable. Similarly, we can find out the same case what will be the observability. We know that the C matrix, so we have 1, 1, and we can also find out CA, which is going to be minus 1 and minus 4. So if you have these two, then I can form my N matrix, and with the N matrix we can write like this. What will be the data of the N matrix? It is going to be minus 3, which means it is not equal to 0, it is observable. So the first case, A case, we got the result as uncontrollable and observable. Now the second case B. So in this case what will be the B matrix? In this case B matrix is going to be 1, 1 and C matrix is going to be 0 and 1. Then we will try to find out what is BAB, which is nothing but M matrix, and B we know already it is 1 1, and if you find AB we will get it as, so from this very clear we can find out -1 -4 and find out what is a M matrix and its determinant. So when you find the determinant of it, it is going to be -3, which is not equal to 0. I can say the system is controllable. Then similarly find out the observability status, also any CA, and in this case CA is 0 1, and we can easily find out what is CA also, that is going to be 0 -4, and it results the N matrix, and find out the det of it. The det of it is going to be 0, which is unobservable. And similarly look at the C case, again we have B 1 2 and C is 2 3. So with these two we can again find out the same procedure, form M matrix and N matrix and find the determinant of it. So if we find the determinant of it, it is going to be non-zero value, which is I am getting it is -6. Det of M is -6, which means it is controllable. And similarly you can find out the observability N is CA. When you take a C is 2 3 and CA will be -2 -12, and with that I can form N matrix. You can find out the det, and det is going to be -18, which means it's not equal to 0. So the system is observable, right? So in 3 cases we have, and we found the results like this. The first case we have uncontrollable, observable. Second case controllable, unobservable. Third case controllable and observable. So when you change the values of ABCD matrices, in fact they are not values, the non-zero entries in the system and 0 entries in the system. And the results that we can write like this, conclusions we can write like this. If in any state model, if A matrix is a diagonal matrix, and if all the elements of B matrix are non-zero, then system is completely controllable. You need not check again, right? So what is the condition? A matrix should be a diagonal matrix, and B matrix should have all the elements which are non-zero values. It is completely controllable. The similar case. So if at all, if any element is 0, then we say it is uncontrollable directly, again without any check. And in case of observability, again if A is a diagonal matrix, if entries of C all the elements are non-zero, we say system is completely observable. If any element is 0, even if you have remaining element non-zero, so we can say that that particular system is unobservable system. So this way we can draw the conclusions, if at all if A matrix is in diagonal matrix. Now, so let us look at the another problem where we have x dot is equal to 0 1 -6 and -8, and x place and B matrix is going to be 1 0 1 1 into U, and y is nothing but 0 1 1 0 into x, and find observability and controllability of the system. Now in this particular system, my B matrix is not the column vector, so it is a matrix 1 0 1 1, which means the inputs are not 1, there are more than 1 inputs. In this case 2 inputs are there. Similarly Y matrix, output matrix also has 0 1 1 0, which means we have more number of outputs. So this is an example of multi input and multi output system. So we can find out the similar case, we write what is B and AB, each second order system. We can write out M is equal to B AB, and which results, because of the B matrix, which results M matrix as it is a rectangular matrix. So we can look at the entries here, 1 1 0 1 1 -14 and 1 -8. So these are the entries of M matrix. So with these entries I cannot directly find the det of the matrix, because to find the det we need a square matrix. Then what will be the order of this? So the order of this is nothing but the maximum possible rank of any rectangular matrix is the lowest order. So what will be the lowest order is 2. So what is the maximum possible rank is 2. Then what we need to do is we need to check, so whether the rank of it is equal to this or not. The order we know, then we can find out the rank. So if they are equal, then we can easily say that particular system is controllable, and otherwise it is uncontrollable. So what I can do is, you can find out the M matrix, which results in the system is rank is going to be 2, which means my system is completely controllable. Similarly, n matrix also, if you form C and CA, it is going to be again rectangle matrix like this. Then if you find the data of it, then it is going to be system is completely observable. So both the case you are getting the rank 2, and the rectangle matrix the lowest order is 2. So we can say the system is completely observable as well as completely controllable. Or else you can take any square matrix, you can check. So if any one possible square matrix giving the date value is non-zero, so we can directly say system is controllable, and in case of observability matrix, system is observable.